we don't catch that whole conversation that we had.
My personal opinion is that because of my experience with the one teacher that made a big impact in my life, that came out of passion, a sincere desire to invest oneself in the future of someone else. And I can't think of a more noble profession than teaching. And when I'm done with my NAEA, one of my goals is to be a teacher for 6th or 7th grade, because that's when the hands stop going up. It's not cool for the girls to be smarter than their boyfriends, and you know, the desire to be inquisitive, to learn, to do well in school. Other pressures come in, the negative peer pressure comes in. So thank you for, on behalf of your students that you have and you're going to have after having this experience. If you reach one, it's worth it. So.
And I had many lengthy conversations with Eddie in the evenings when we went out for dinner and stuff. So he's a very genuine, very interested in the arts, which obviously it came to my heart. The plane. Let's talk about this a little bit. It's a Boeing 747, the SP, which is Special Performance. It is one of 45 that were built, which means that it's about 14 meters shorter than a regular 47, a little bit lighter. And in the back there, in the fuselage, you'll see it, there's a hole, there's a cavity. And in that cavity is the 2.5 meter diameter telescope. It's an infrared telescope. And it flies above the water vapors in the cloud barrier up into the stratosphere, about 45,000 feet up. It flies at about 540 miles per hour, and the most interesting thing about this, or one of the interesting things about this, is that with this cavity in the back, that bulkhead that opens up, there's a hole flying that high, that fast at that altitude, and it doesn't rip the tail fin off. This is an engineering feat, and we actually got to meet the chief engineer when we were out there taking a tour of the facilities, and Janet, yes, a woman, talked to us about creating this, and how do you create this such that they had to modify a 747 such that it wouldn't rip the back off. It's a 17-ton reflective telescope. A reflective telescope basically is a telescope that uses mirrors. The wider the mirror, the primary mirror is, which is the 100-inch diameter, the more light it can gather, and then it can actually give you a brighter signal when you collect the data. It's the world's largest portable telescope that's not ground-based. It flies. And then it can, another interesting thing about this in the feat of engineering is that the telescope, if you think about this, you're flying 540 miles an hour, 43,000 feet up, and there's a lot of turbulence. And as you're standing in the cavity of the plane, and you're looking at the telescope, which is that top image up there, so we're at the console and we're looking at the telescope, and it's bouncing and it's shaking all over the place, and you're like, wow, it's, a lot of turbulence out there. And you're like, wait, no, that's not correct, because you know what? That telescope is not moving. It's the plane that's bouncing and shaking. It's the reverse. So what they've done with the telescope is they've created a gyroscope with an oil film layer in between it, a double gyroscope. And then the plane itself goes around the telescope. So as it's flying, the plane is shaking. But guess what? That telescope is not moving, which is, if you think about it, is another engineering feat in itself, to be able to do that and to create that telescope in a system such that it won't shake as you're flying. It's quite interesting, and I have a lot of film footage of just that, and you look at that and you just see this thing just shake, and you're just like, well, what's that about? And I said, well, that's why. And then the other interesting thing about this telescope, which is the first one, is that they have interchangeable lenses. So this makes it able to reach the wide, if you remember the spectrum, the wide field of wavelengths. Because this silver part there Think of it like a camera body. You have the camera and you can change the lens out depending on what you want, the depth of field that you want, and you change the lenses. Well, with this, depending on what segment of the wavelengths that they want, the electromagnetic field, spectrum, excuse me, they change the instrument. Now you can't change it in flight, so they have to plan the whole flight and the patterns around this instrument. We flew with XCs, it's called, infrared wavelengths. And then our second time we went, it was with forecast. 2 different instruments, but able to capture different portions of the infrared spectrum. So let me explain this. Why is this so interesting, and why do we need to spend all this money? Why does NASA need to invest into the SOFIA program? And why are they taking public educators into this program to educate us? Well, this, what you're looking at, is called atmospheric transparency. Basically, compare it to sitting in a car, and it's pouring rain outside. Okay, downpour, like horrendous downpour, the top image, and your wipers go. Now the wipers can't really keep up with the downpour. The rain's coming down, it's coming down your windshield, and you can't really see very clearly. You might get a little bit as the wiper goes by, but it's downpouring so hard that you can't actually see out. That's the blue up there. That blue is water vapor and particulates in the atmosphere that blocks the infrared wavelengths. So as you're looking through the telescope, any ground-based telescope, and that one is the Observatory of Mauna Kea, Hawaii, at an altitude of just under 14,000 feet, you're looking at the stars, or the Sombrero Galaxy here, and because the water vapor in the atmosphere, you're not able to get a clear image of it. But when you get above that, say 45,000 feet, and that's where this image was taken, you can see how the wipers can keep up with the rain, so to speak, and then you can get a clearer image of what's out there, which makes SOFIA such this wondrous flying observatory, which researchers from all over the world put their applications in so they can study certain aspects of the universe. Does that make sense? Mm-hmm. And again, what makes it so interesting as well is that with the infrared imagery, you're able to get a better snapshot of the makeup of our photo, of the galaxy, of the stars and the planets that are out there, or asteroids. So, as Howie likes to say, it's not what you can see with the naked eye, it's what you can't see. And with visible light, when you're looking at a planet, there you go. That's what you see. As soon as you put the infrared filter on, the colors come alive. And this is actually what attracted me to the program. The colors are so vibrant that you can actually bring that back into your classroom and create these wondrous pieces of artwork. So when you use the infrared, just so a little sidebar here for all those who are studying science out there, that every element out there has a very unique emission spectrum. Basically, it's a footprint or a thumbprint. Okay, so when you look at it, it's called spectroscopy, which is actually one of the most horrendous things I've ever heard. It doesn't sound that pleasant. It has a thumbprint, so when you're looking at this, you can start telling what the elements are, the gases, nitrogens and the hydrogens. And I believe the hydrogen is the pinks and the reds. So the more hydrogen it has, those colors will show up. And the more, say, nitrogen it had, those colors will show up. So it gives you a better composition of these planets, so you know what their makeups are. A myth buster that I want to bust right now is that we were not weightless. We went up 45,000 feet, which is above the cloud barrier, above the water vapors and the particulates in the atmosphere. We're still in the stratosphere, and that's what we fly at. That's the highest that this plane can safely go. Would they go higher? Absolutely they would. But because of the weight of the telescope and the amount of fuel that they have on the plane, the higher you go, less oxygen there is, and the more fuel you burn. It can only go up safely to that elevation, altitude. Space, by the way, is defined at 65 miles, 62 miles up. That's, if you could draw a line, that's where space actually begins. Mount Everest sits at about 29,000 feet, and let's see, the Willis Tower here in Chicago sits at 1,451 feet, to put it in perspective.
I can't really explain the feelings I get when I think about this. Tomorrow morning I leave, and it's, you know, it's going to be sensory overload for me for the entire week. It's going to be grueling. It's going to be very difficult. The sleeping patterns are the same. But I'm looking forward to it. Very much forward to it. And I just hate everything. And so I'm excited. Yes, I'm excited.
I was extremely excited. When we got the phone call, I'm one of these people that when you apply for something, then I kind of put it out of my mind. I don't think about it until it actually happens. And little sidebar here, our secretary at school calls me on my phone, and she's like, "Do you know someone by the name of SOFIA?" And I'm like, "No, I don't. Is it a parent or something like that?" And she's like, "Well, they just called saying if you were employed here." And I'm like, Sophia? Sophia? You mean Sophia called? And she's like, yeah, and then she kind of caught on. She's like, well, you know, they were just checking to make sure that you were a teacher here at school. And, you know, of course, I'm just... and I'm just like, oh, okay. So, of course, yeah, I do what every teacher's not supposed to do. I pick up my phone and I text Howie, who's 4 floors up on the other side of the building. And I said, Howie, did you just get a phone call? I said, Sophia just called to check to see if we were employed here. I said, why would they do that? They wouldn't do that, really? And he's like, oh, I don't know. So, you know, of course, I go up to the office, and I'm just like, Carmen, who's our secretary, and I'm just like, I said, who exactly called? She's like, oh, they're on the phone with Dr. Dawkins, our principal. And I'm like, oh, well, she's like, I don't know, they were just calling. And I'm just like, okay. And then that was it. You know, during my lunch, I go up and I talk to Dr. Dawkins, and I'm just like, I said, Rose, I said, did you get a phone call by any chance? And she's like, no, I don't know what you're talking about. You know, so of course I'm just like, oh, okay. So that night when we got home, it was a phone call, and they accepted us into the program. And I have to say, I was beyond thrilled. Being an art educator, being the only one in the program, being accepted into it, knowing that NASA just gave us a stamp of approval on the importance of the arts, being able to go out there and talk to Eddie, you know, the program director of SOFIA, just really reinforces the need for innovation and creative thinking and the importance of the arts within all the subjects, not just astronomy, not just science. So where did we go? We went to Palmdale, California, which basically consists of the Armstrong Flight Research Center and malls. That's it. You either work at the center or you work at the malls, and I've never seen so many strip malls in my life, and that's pretty much the makeup of it. It was a grueling week. We actually, the first time we went out was beginning of school. It was in August. We had flight engines problems, so we never got off the ground, so for 4 days in a row we sat in the mission briefings, and I'll get into those in a little bit. 4 days, and I'll tell you, the emotions just went up and down, up and down. And by that fourth day of sitting in the briefings, you're sitting there like, you know what, even if you got the engine fixed at this point, I don't think I want to fly. I'm seeing that you just put 4 days into trying to fix this one engine that was giving you problems. So they flew us back out. And when we went back out, we went out on a Wednesday night, and this is our schedule. So we flew out Wednesday. You have a very late dinner, about 10 o'clock at night. You stay up as late as you possibly can to kind of acclimate us to being up all night on these flights. And then we have to be ready to go at 11 o'clock in the morning. And I'm just like, you want us to sleep in on Thursday morning, but 11 o'clock's not really sleeping in when you stay up until 2. Teacher time, I guess, is what they're doing here. So 11 a.m., we're ready to eat. Again, we are doing that. We're going to the facilities, we're having tours, we're getting our debriefings, and then we fly. So at 4:25, we're on the plane, and we are taking off, and we actually landed at 2 o'clock the next day in the morning. It's a little bit shorter flight. There's a few issues going on, technical issues, so we ended up landing a little bit earlier. Again, going to sleep, waking up, getting ready to rock and roll by 1 o'clock. And then our takeoff that night was 11 o'clock. I mean 7 o'clock, excuse me. And we landed at 5 o'clock the next day. These are overnight flights where you are not allowed to sleep. You could, but they really frown on it. And they are highly intense. 24/7 learning. We were nonstop. So we had the 12-week class. And I'm very glad we had that. And then while every minute we had out in California, we had the books out, we had the abstracts out, and we were studying what it is that we're looking for and at. And it was nonstop, and I learned so much. It's one of those crash courses in astronomy. But it really brought to life what the importance of this research is and is needed. In between learning, we're having tours of the research center. This is a fair in astrophysics.
You have to go to 2 lids, take the 12 out of the detectors, beautifully engineered, so that you don't have to tear the whole thing apart.
Talking about one of the scientific instruments.
Different components. And so this instrument is one that...
And this is the facility where they coat the mirror. And that's a cryogenic tank behind them, where they put the mirror and they drop it down to, I believe, 7 Kelvin. And when you freeze the metal that cold, all the particulars stick right to it. So that's how they get the smooth coating on the mirror itself, on the base mirror, which has to be recoated every 7 years. I think it's 6 or 7. Something that was of notice of all the individual researchers and scientists is their passion for what they do. They absolutely love what it is that they're doing, and that actually shows when they're talking to you, and no question you could possibly ask them made you feel silly about asking. Lots of times I was asking questions that, you know, more on the sensory side when I'm talking to them, not having a well vocabulary when it comes to astronomy and what it is that they're looking at, as strong as some of the other educators. And they were like, that's a good question. I didn't think of it like that. So again, bringing to them a different way of looking at things. And they were all very genuine when they were talking back to us, which made for a wonderful flight because you're up there for 10 hours, you're talking to everybody and you're interviewing everybody, and they so much want to share with you what it is that they're doing. The mission briefings. We sat through 6 of these actually. We got to know everyone very well. In this room, it starts about 2 hours before you take off. You get the phone call in the morning saying you're flying. Well, you get all pumped up, psyched up. You grab all your stuff, your gear. You go and buy your lunches or your dinners because there's no food provided on the plane. It's a flying observatory, so whatever you want to eat, you have to bring on yourself. And then you sit in this room with about 35 other people. And what we're doing is they're going down the list of who's going to be on a flight and the ones who are doing roll calls, and they're also doing the ones who are giving reports. So the pilots, the flight directors, the safety techs, the meteorologists, the mechanics, the flight planners, the scientists, they're all giving their reports about. And it's amazing to see the synergy that has to go on among so many different departments to get one plane off the ground. And then here is our hero walk. So that has a lot of emotion behind that one as well, because we did fly out in November and we were grounded for 4 days in a row. We weren't able to fly. And like I said earlier, the emotions were up and down with everybody, not just us. Sitting there thinking we're flying, and then, you know, an hour later, 45 minutes later, you realize you're not flying. To November when we were flown back out and we actually were flying. I mean, the whole room just started cheering that we were able to go. It was that much of an emotion. So, of course, we had our hero walk to the plane. and now we're on the plane. Now, this is a little footage from the documentary that's being made